In today's lesson, we're going to be talking about transformations. You have been looking at parent functions, and we're going to take those parent functions and perform some transformations. Let's look at our list. The first one we have is x minus h. H represents some sort of number, and this is our transformation. If we have an x minus h, that means we have a horizontal shift left or right. It's in with x, and so we are shifting along the x-axis. How do we know if we're going to shift left or if we're going to shift right? Well, if our h value is less than 0, for example, x minus a negative 2, which you may also then see as x plus 2, we'll know we'll shift left. If our h value is greater than 0, in other words, it's x minus a positive 2, then we are shifting to the right. So it's a little counterintuitive when you're looking at something like x minus 2, you might be thinking, oh, that needs to go left, but remember, this is actually x minus a positive 2. Also, you can think of it as the x-intercept. When you're finding the x-intercept, you always set y equals to 0. So we would have x minus 2 equals 0, add 2 to both sides, and you end up with a positive 2 x-intercept, not a negative 2. This is the one transformation that most people forget. Okay, let's move on to k. On the end, k on the end means shift up or shift down. So it's whatever it is, because y is over here. If we're shifting along the vertical axes, then y is in fact the actual value. So if we have a plus 2 on the end, we would shift up plus 2. Our next one is a in front of the x. This is like y equals mx plus b. The m is our stretch or our shrink. And how do you know if it's a stretch or shrink? Well, if it's a stretch, we have a factor of some number greater than 1, like 2 or 2.5. If it's a shrink, it means we have a fraction, like 1 over 4. And you can picture it, if you were to graph 1 over 4 as a slope, you would only go up 1, and you would go up, or you would go over, I should say, 4, creating a very shallow slope, shrinking it down. Our final two are reflections. Anytime you see a negative, remember those are reflections. If we have a negative out front, just like when we did our evaluations of functions, that means we have a negative y value. In other words, we're reflecting over the x. If we have a negative in with the x, we have a negative x value, so we'd be reflecting over the y. Now let's put these to the test. Let's try them. Let's start with this function here. This is our squared function, or quadratic as you know it. In order to graph these, there's 3 steps. The first step is to write out the parent function. So y equals x squared is our parent function. The second step would be to list your 3 key points that come from that parent function portfolio. If you don't remember what those are, look back at your parent function portfolio. For a squared function, our key points were negative 1, 1, 0, 0, and 1, 1. These 3 points are really important because that gives us the heart of this function. It'll give us the vertex and the points at which it curves up. If we pick some random points out here, we won't get to the meat of this function. Okay, the third step then is to figure out our vertex. So what is our vertex? If we look at this function, we don't have any transformations to the h, but we do have a transformations to the k. Our vertex, if you remember back, is always going to be whatever the h is and whatever the k is. That's a really important key point. In this function here, we have no h value, so that's 0. Our k value is 2, so that's 2. So step 1, write the parent function. Step 2, list the key points. And step 3, write the vertex. Now we're ready to transform. Okay, identify the transformation. We have a plus 2 on the end. This is our k as we stated, so we're going to shift up 2. Since we want to use these key function points to start with, that's what we're going to transform. We're going to leave x the same because we don't do anything to x, and we'll keep these key points in place. Our y's are going to shift up by 2. So we'll take all of our y values and we will add 2 to those. We'll start with 1, 0, 1, and then we'll add 2. Once we've added 2, now we have our points and we can graph. So graphing this, we would get negative 1, 3, 0, 2, and 1, 3. Notice that we have our 3 key points, but those have been transformed. Okay, let's look at a second example. So remember, we start with our parent function, we list our parent function key points, and then we transform those. Let's start with our vertex. Our vertex is h and k, remember, and our h value is always going to be the opposite, so this is really x minus a positive 1, so we have plus 1 here. We have no k transformation, so that's 0. What is our transformation? We said we move to the right 1. That is our transformation. Shift to the right 1. That will affect our x values, but not our y values. So we'll keep our y values the same as 1, 0, 1 from the parent function. But our x values we will transform. We will add 1 to each of our x values to come up with some new x values. So 0 plus 1 will give us 1, and 1 plus 1 gives us 2. Now we're ready to graph. And you can see after we graph that our vertex is in fact at 1, 0. Let's do our last problem. Pause the video and try this on your own. For this last problem, here's our key points. Let's identify our vertex then. We don't have any adjustments to the h, so that's going to be at 0, and then we shift down 3. So we know that our vertex will be at 0, negative 3. Let's go ahead and think about our transformations. Well, we have a negative out front, so that's a negative y. Anytime you have a negative y, that means you're going to reflect over the x-axis. And when you reflect over the x-axis, you're really multiplying y by that negative. So we have negative, and then the 4 is our stretch. We're multiplying that by y. You're going to shift down by 3, and that again affects the y value only. So here's our 3 transformations. Applying that to our y values, we get negative 7, negative 3, and negative 7. Now we're ready to graph. Notice on our graph that our vertex is indeed at 0, negative 3. You can see that we reflected over x. It is steeper, therefore the stretch of 4, and we did shift down 3. It's important to always check your work against what you identified as being the transformations. Let's look at a couple more. Let's look at this square root function. Everything is the same as far as transformations. So when you look at this plus 2, you have to think to yourself, this is in with our x, so this is a shift left or right. Since this is really x minus a negative 2, we know that we are going to shift to the left 2. So we can identify that transformation right away. Shift to the left 2. Let's think about our vertex. Well, we shifted to the left 2, so that's our h. We don't shift up or down, so that's 0. That should be our vertex, or our starting point. Let's take our values and adjust them. Since we're shifting to the left 2, we would have 0, minus 2, 1 minus 2, and 4 minus 2. So our x values we are adjusting by shifting to the left 2, and we end up with negative 2, negative 1, and 2. Our y values are going to stay the same, so those will be 0, 1, and 2. Notice these key points are different than our last key points. Remember that these are listed on your parent function portfolio. So if we graph these key points, negative 2, 0, that's our initial point or our vertex, negative 1, 1, and 2, 2. If we graph that, we have our square root function, and notice that it has been shifted to the left 2. In our final one down here, we have a negative x. So in other words, we're reflecting over y. So we're going to multiply all of our x values by a negative 1. So we would get 0, negative 1, negative 4. Our y values, on the other hand, are going to stay the same at 0, 1, and 2. If we graph this function, we have our vertex here at 0. Notice that our vertex, we didn't shift h and we didn't shift k, so we should still be at 0, 0. Negative 1, 1 is our second point, and negative 4, 2 is our third point. And if you examine this graph, you can see that we did reflect over the y-axis. So remember, when you're graphing functions, there are 3 steps. First, identify the parent function. Second, list the key points. Third, find the vertex, and then you're ready to go. Before we conclude this lesson, let's go ahead and look at a graph and see if we can write an equation from the graph. Well, when we're noticing the graph, we should decide which parent function does this represent. And since we just did these, we know that this is y equals square root x. In order to determine the equation, we need to look at our vertex or our starting point. In this case, we have that this is 0, 5. So we didn't shift anywhere for h, but we did shift up for y. So what we'll do is we'll go ahead and put that into our function, plus 5 on the end. Now, we can't identify necessarily by looking at this whether we have a stretch or a shrink. We know that we didn't have a reflection, but we might have a stretch or shrink. So let's put in an a value. We don't know that. And let's see how we can find that. In order to determine our a value, we would need to trace our function until we found a point that we could use, like right here, which is at 4, 7. This is an x and y, and we have an x and y in our equation. So we'll plug in the 7 here. We don't know a, and for x we know we have a 4 that goes with our 7, plus 5. Let's go ahead and solve for a. So we'd subtract 5 from both sides, and we would take the square root of 4 and get 2. Divide both sides by 2, and we find that a is actually just 1. So our equation for this graph is going to be y equals the square root of x plus 5. We only have one transformation. We can try that again, but this time with a squared function or a quadratic. So let's go ahead and write our parent function. Y equals x squared. Now let's look at our vertex. Our vertex is at 4, 3, so we can add that into our parent function. We know that we shifted to the right 4, so this is actually going to be minus 4. And then we shifted up 3. The only thing we don't know then is our a value. It looks like we have a reflection, so we probably have a negative a value, but we can find it if we can solve for it. So tracing our function, we find this key point at 2, -5. Let's go ahead and plug that key point in. -5 would go in here for y. We don't know a. 2 for x, and now we can solve for a. 2 minus 4 is -2, and -2 squared is just 4. If we subtract 3 from both sides, we get -8 equals 4a, and if we divide by both sides by 4, we get -2. So in fact, that shows that we do have a reflection and we have a stretch of 2. We can write our final equation as y equals -2 x minus 4 squared plus 3. And that concludes our lesson on transformations. So hopefully at this point these transformations are coming back to you. But remember, the transformations are the same no matter which parent function you're applying them to. So as long as you keep these in your notes and you refer to them, you should be able to identify the transformation and use the transformations to graph functions, as well as being able to write a function from a graph.